Hi, we are from Group 15. The chosen title for our IDP project is IoT-based notification and monitoring system for unattended children in vehicle to prevent hot car deaths. My name is Jainiswari Anak Perempuan Jyoti. My members' names are Gautam Anak Lelaki Sarawana and Munira binti Muhammad Nasir. Now, I would like to present the problem statement of our project. Hot car deaths due to heat stroke, or better known as hypothermia, involving toddlers are increasing all over the world. In more than half of these deaths, the parent or caregiver forgot that the child was in the car. Children are more prone to hypothermia than adults. Thermoregulation in a child is less efficient compared to adults. A car parked for 10 minutes can heat up to 20 degrees Celsius. Leaving a toddler in a vehicle for some time is a threat to the toddler's life. Not many people are aware of the risk leaving a toddler in a vehicle for long hours. Statistics have proven that toddlers' deaths in hot cars are due to parent or caregivers' negligence. Right now, we are looking at the bar graph showing the recorded cases of child deaths from heat stroke in the US. On an average, 38 children under the age of 15 die each year from heat stroke after being left in a vehicle. In both 2018 and 2019, a record number of 53 children died after being left in a hot vehicle, followed by 25 cases in 2020 and 10 cases in 2021. Meanwhile, here in Malaysia, the reported cases of toddler dying in a hot car is lower compared to Western countries, as only a case recorded in 2020 and one more in 2021. However, the in-car death among toddlers is preventable in Malaysia. Thus, a system has to be implemented in a vehicle. The system will then monitor the toddler's motion in the vehicle and also notifies the parent of rising car temperature. Implementing this system in vehicles in the future will help preventing child deaths in car due to parent or caregivers' negligence. Next is project objectives. This project aims to develop an IoT-based notification and monitoring system for unattended children in vehicle to prevent hot car deaths. The objectives of the project are as follows. Number 1, to design a system that can sense the existence of child in a car seat. Number 2, to design a wireless system that triggers the sensors when temperature is above 30 degrees Celsius and sends an alert to notify parents of emergencies. Number 3 is to design a system that comes with an application that can provide info on the toddler's motion, car temperature reading, and alarm. Right now, we are going to look into the scope of the project. This prototype will cover the scope as follows. Camera access in the system to monitor the toddler's motion in the vehicle by the parent using an application called Blink. Camera monitors toddler and captures movements to be sent to parent through the application. PIR sensor and ultrasonic sensor to detect the motion of the toddler in the seat of the vehicle. Temperature sensor to detect any rising temperature. Example, when temperature of the car exceeds 30 degrees Celsius, a notification is sent to parent. Buzzer to alert the pedestrians of the rising car temperature when temperature exceeds 30 degrees Celsius. Parent able to reset the buzzer through the Blink app. A servo motor is used in the system to scroll down and up of the vehicle's windows using Blink application. Last but not least, a Wi-Fi is used to connect ESP32 microcontroller and ESP camera to the internet.
Next, I'm going to present the overall project flowchart. We are using PIR sensor and ultrasonic sensor to detect the child. The angle of detection of the ultrasonic sensor is 15 degrees. So, if the child is located at the location that the ultrasonic sensor can detect, then PIR sensor will detect the child. If the PIR sensor or ultrasonic sensor detect the child and the temperature reaches 30 degrees Celsius, then the buzzer will on. Then there will be a notification sent to the smartphone of the parent, and then the parent can open the Blink application and monitor the child using the camera. The parent can click on the power window button in the Blink application in order to slide down the power window so that the oxygen can flow into the car and the temperature will drop, and at the same time the oxygen concentration will rise. The parent also can Switch off the buzzer by clicking on the buzzer button in the Blink application. To present the block diagram of the ESP32 microcontroller. The ESP32 microcontroller is powered up by using 5V 2A power supply, and the input is ultrasonic sensor, temperature sensor and motion detect sensor. The ESP32 microcontroller is connected to internet via Wi-Fi, and the token of the Blink application is used to connect the Blink application to the ESP32 microcontroller. The output of the ESP32 microcontroller is servo motor, buzzer and OLED display. Next, for the block diagram of ESP32 camera, the ESP32 camera microcontroller is powered up by using 5V 2A power supply, and the output we can monitor the child by using the camera in the Blink application, and it is connected to internet via Wi-Fi. Next, I'm going to explain about the schematic diagram. As an example, for the input, we can see the PIR sensor. There is 3 pin. First pin is for the V-in for the supply. The third pin is ground, and the second is for the signal. So for the PIR sensor, we are using pin 14 GPIO in the ESP32 microcontroller. Same goes to other input and output. Next, I will explain the Blink interface in the smartphone of the parent. So first, this one is to control the power window in the Blink application, so that we can swipe up and swipe down the power window. This one is for the ultrasonic sensor. It will detect the baby in the position. So if the ultrasonic sensor detect the baby, it will stay occupied, and if none, then it will state none. This is the measurement of the temperature sensor. This is to set the ultrasonic distance limit. This is to set the temperature limit. This is for the PIR sensor. If got movement, then it will state movement. If got no movement, it will state none. This one to turn off the buzzer in the Blink application.
Next, I'm going to present about the material cost of this project. So here is the list of electronic component that we use for our project. The designing of this project involved in constructing the real prototype, which is the cost of our project is about 247 ringgit and 40 cents. After we do some survey about the similar product that are already sold in market, we decided to market our product in the price of 450 ringgit, which is affordable for the customer to buy it. Next is for health and safety. Our project is in line with Sustainable Development Goal in Goal 11, which is the goal is to make cities and human settlement inclusive, safe, resilient and sustainable. This project also aims to improve safety and provide more possibilities to minimize the danger that infants will die from heat stroke. So from that, the parent would feel safe and secure. Next, I'm going to present about environmental and sustainability consideration. The environmental impact and sustainability are focused because it affects all aspects of our lifestyle. For this project, we have employed different methods such as the use of recycled materials as the prototype of the project, such as box and polystyrene. Since we are using IoT, sensors and devices linked wirelessly will eliminate unnecessary data looping, where data looping is the entire data collection process from start to finish and back to start again. This IoT will have a great impact on sustainability, and by using low power and wirelessly linked sensor will help to sustain the environment. The next part is for project value. So here at the left side, we can see that the product that already sold in market, which is Cybex Eternis as sensor safe convertible car seat. The cost of this project is 1,479 ringgit and 6 cents. The features of this product are using alarm, sensor safe clip, and rear facing mode. While at the right side here is for our project, which is IoT based notification and monitoring system for unattended children in vehicle. The estimated cost for our project is 450 ringgit. The features for our project are using buzzer, ultrasonic sensor, ESP32 camera, PIR motion sensor, DHT temperature sensor, and also power window system. So from the comparison here, we can see that our project has the lower cost comparing to this one, and the features here also uh, improve in our project. The reason why we are choosing to do this project is because it can help in reducing the occurrence of accidents involving heat stroke among children because of being trapped in a car. Using modern tools, IoT-based wireless sensor and notification help to decrease human error because of negligence due to forgetfulness. By providing a real-time data, the system gives parents with an immediate action where there are also a power window system that are designing in this project. For our project, it is not only specific for parents with a baby in their family, but also can be implemented as a medical application to monitor the patient in hospital.
Conclusion. In summarization, we have designed the proposed title of IoT-based notification and monitoring system for unattended children in vehicle to prevent hot car deaths for the safety of the children. The system was designed with a low cost and also equipped with sustainable feature. The objectives of the project have been achieved. This low-cost project we believe will solve safety issues of parents or caregivers on leaving toddlers in a vehicle with the implementation of the proposed system. Hopefully, this system can be applied in Malaysia and all over the world to prevent the death of toddlers in the vehicle because of the heat stroke.
Now the project will be presented by using the prototype. So this prototype is, we assume this as a car. So first of all, let me clear about the ESP32 camera first. So this is the ESP32 camera, 32 camera. So we can monitor by using the Blink application, and this is one connection. You can see I'm not connected to the Wi-Fi. Now we can see the teddy bear here, but the internet connection is slightly slow. There is a delay. You can see it's my hand. There's a delay because of the weak internet connection. So next, for the ESP32 camera, this is the OLED panel display, ESP32 microcontroller, ultrasonic sensor to detect the baby, and if the baby is not in the range of ultrasonic sensor, maybe the child is here and moving, then the PIR sensor can detect the baby. So we are using two sensors to detect the baby. First one is the PIR sensor and another one is ultrasonic sensor. So this is the servo motor used to slide down the power window to let the oxygen flow in the car. So now the temperature is 33 and we set the limit is 36, so the buzzer or no notification will be sent.
and then if the baby position is missing, so the ultrasonic didn't detect the baby. Sometimes I cannot detect the teddy bear, but when I put my hand here, you can see that it's occupied. It means the baby is there. And movement, because of I move my hand, now it's none. So the system will give notification when there is a baby occupied or there is a movement, and the temperature must be higher than 36. So now if I put let the movement become none, okay, then the temperature limit, if I put 31, 33 is higher than the 31, but it won't be sending notification because it didn't detect the baby. So if I put my hand, it detect the baby, so there is a movement and there's notification will be sent. So when there is notification sent, then the parent can monitor the baby by using the camera. So you can see I put the teddy bear just now, but it's because of the delay. Just now it's moving, so we can turn off the buzzer, and then we can use the power window button to slide down the power window. So if I press this, so we assume this as a power window. We can use it to slide up and slide down. So if we slide down, we can allow oxygen to enter the car.